Hello friends, we can select the questions from the chapter real numbers from this sample question paper. Okay. So here we have one assertion and the reason for it. We have to choose the correct option. Okay. So first assertion is HCF, highest common factor of any two consecutive even natural number is always 2. So we know highest common factor, how can we find? Any two even consecutive natural number. Okay. Suppose we are taking 2 and 4 and highest common factor is 2, right? 4 and 6, highest common factor is 2. Any number you can take, 98 and 100. If you are taking highest common factor, you will get 2. Okay, so that is true. First assertion is true, and the reason they are giving, even natural numbers are divisible by 2. So even natural numbers, any even natural number, you can divide it with 2, right? 88 divided by 2, you'll get 44. It is divisible by 2. So that is also true, but the reason is not explaining about HCF, highest common factor, right? It doesn't mention anything about the highest common factor. So this is not the correct explanation. You can write, so assertion and reason are true, right? Both are true, but reason is not the correct explanation for A. Okay, it is not the correct explanation. Okay, find the highest common factor and least common multiple of 480 and 720 using the prime factorization method. Okay, so they have mentioned the method. It should be prime factorization. HCF, I'm going to find it like 480 prime factorization. I am dividing it with 2. I will get 240. Again with 2, 120, 260. Okay, hope you know this method. 230, and I can use again 2. So it will be 15. Then the prime number should be 3. So I'll get 5. Again the prime number is 5. So I'll get 1. So I can stop here. So 480 I can write as 2 times 2 times 2 times 2 times 2 times 3 times 5. Correct? And what about 720? Can do it here. 720. Again 2. 362s are 720. Again 2. 182s are 360. Then 2. 90. 2. 45. 2. We cannot divide it with 2. 3 we can take. It's 15. Again 3. So it will be 5. Again 5. It will be 1. Okay. So 720 I can write like 2 times 2 times 2 times 2. Okay. Then 3 times 3 times 5. We can select the common numbers. So 2 and 2 are common. Only one time we are taking, right? Then another common. This is common. This is common. We cannot take this 2 because only 3 is here. So 3 and 3 we can take common. We are checking the common numbers. Okay. So highest common factor is from each group we have to select only one number. 2 times 2 times 2 times 2 times 3 times 5. 83 is a 240 is the answer. So this is the LCM. Sorry, this is the HCF. Okay. So from here itself we can do LCM without doing any further calculation. We can just multiply these numbers also. We can take this number also, 2 and 3 additional to this 240. That means 240 is already there, and we can take 2 and 3 also. Those are without any pair, right? So we can take that also for finding least common multiple. Again, if you want, you can do again the prime factorization, and you will get the same answer. 240 times 2, 480. 480 times 3, 1440 is the LCM of these two numbers, 480 and 720. Okay. Our question is, the HCF of 85 and 238 is expressible in the form of 85m minus 238. Find the value of m. So first we have to find the HCF of 85 and 238. So 85, how will you find? The prime factorization method, you can take 5, right? So 1 5 is 5, 7 5s are 35. Okay, only that much. The 17 is a prime number, so we can stop there. And what about 238? You can use 2. 1 2 is 2, 1 2 is 2. Then 1, 9 2s are 18. Again, what number we will take first? It's 119. If you are checking with 7, 1 7 is 7. Yeah, it matches. 7 7s are 49. So again, 17, 1. So common number, highest common factor is 17, right? Because here you can see only the common number as 17. 17 is the highest common factor. So 17 can be expressed as, it is written 85m minus 238. So 85m minus 238 equals 17. So 85m equals 238 plus 17. Okay, 238 plus 17, 255. So m should be 255 divided by 85. 17, 51. So 3. 17 3s are 50. With m's value is 3, that is the answer. Prove that root 3 is an irrational number. So I have written here something. Let us assume root 3 is a rational number. So the opposite thing we are imagining, okay, assuming. And finally we will get our assumption is wrong. So we can prove root 3 is an irrational number. Then there exist positive integers p and q such that root 3 equals p by q. Any rational number we can represent it with p by q form, where p and q are integers and co-prime numbers. Okay, we are assuming they are co-prime numbers. I hope you know what is co-prime number. Co-prime number means if there are two numbers with highest common factor only 1. Suppose if you are taking 4 and 7, the highest common number of 4 and 7 is only 1. No other common number is there. So that those are co-prime numbers. So we are assuming here p and q are co-prime numbers. There are no common multiple for p and q. Okay, that's very important here. Now root 3 equals p by q, you know. Okay, so we can take square of 3, right? Root 3 square. Each side we are squaring. Root 3 square and p by q square. Okay, so you'll get 3 equals p square by q square. So p square equals 3q square. Okay, so p square equals 3q square means p square is a multiple of 3. Okay, if you multiply something with 3, you will get p square, right? So p also will be divisible by 3. P is also divisible by 3. Okay. So we can write p is also divisible by 3 means we can write p equals 3c, any number. Okay. When you multiply with some number, you will get p. Even maybe 1 or 2, whatever number, if you multiply, you will get p. That is the meaning of this. Okay. Then p square equals 3 square c square. That is 9c square, right? So we can equate with this equation. Okay, substituting in this equation, p square equals 3q square. So p square we already found, it is 9c square. So 3q square will be equal to 9c square. Okay, so what about q square? Q square equals 9 by 3 c square, that is 3c square. So q square is a multiple of 3. So definitely q is also divisible by 3. Hope you are getting the point. Q is also divisible by 3. Okay, that means Q equals 3 something, 3D or something, whatever number. So Q and P are multiple of 3. So there is a common number 3. But we assumed that there should be only the common number 1. Highest common number should be 1. But here we got the highest common number as 3. Okay, not highest common number. Other than 1, there is a common number 3. Okay, so our assumption got wrong. and hence we proved root 3 is irrational. Hence proved.